Welcome back with a new math tutorial. In this video, we are talking about constant rate of change. At the first, what is the meaning of the rate of change? Rate of change is the ratio between the change of y to the change of x. If this change is constant, it means we have a linear relation. So the linear relation that has a constant rate of change. So what is the meaning of linear relation? The linear relation is the relation which is represented graphically by a straight line. So if the rate of change is constant, we have a linear relation. This linear relation represented by a straight line. The second part of the lesson will talk about the proportional relationship. The relation is proportional if the ratio between y to x is constant. So the difference between the rate of change and the proportional for the rate of change will just find the change of y over the change of x. But the proportional will just find the relation between y to x. Just divide the value of y over the value of x. If the rate of change is constant, the relation would be linear. If y over x is constant, it means the relation will be proportional. You can find if the relation is proportional or not from the graph if the straight line passing through the origin point. Now we need to determine whether each relation is linear or not. If that's linear, we need to find the constant rate of change. And after that, we need to check if the relation is proportional or not. So I will start with the rate of change. To find the rate of change, we will start from x. That is the first number now for x. 3, 6, 9, 12. You will find that in all of the values we increase. It means we add. 3 becomes 6 if we add 3. 6 becomes 9 if we add 3. 9 becomes 12 if we add 3. Now for y. 170, 140, 110, 80. 140 minus 170 equal to negative 30. 110 minus 140 equals to negative 30. 80 minus 110, it will be equal to negative 30. If you look at all of the values of y, you will find that it will be decreased, and all of the values of x are increased. Now we need to find the rate of change. The change of y is negative 30, divided by the change of x will be equal to negative 10. The change of y equal to negative 30. The change of x will be equal to 3. It will be equal to negative 10. The change of y negative 30. The change of x is equal to 3. It will be negative 10. Once we have all of the rate of change are equal, it means we have a constant rate of change. It means this relation is linear. And the constant rate of change now will be equal to negative 10. Now we need to find if the relation is proportional or not. Just by dividing y by x. 170 divided by 3 and 140 divided by 6. 110 divided by 9. 80 divided by 12. If you look at the relation between them, you will find that all of the fractions now are not equal. Once we have here all of the fractions are not equal, it means this relation is not proportional. Now in question number 2. In x we have 5, 8, 12 and 24. From 5 to 8 we add 3. 12 minus 8 equals to 4. 24 minus 12 will be equals to 12. Now for y. We have 15, 24, 36 and 72. 24 minus 15 will be equal to 9. 36 minus 24 equals to 12. 72 minus 36 equal to 36. Now we need to find the rate of change. As we said before, the rate of change, which is the change of y over the change of x. Don't divide x by y. Just divide the change of y over the change of x. 9 divided by 3 will be equal to 3. 12 divided by 4 equals 3. 36 divided by 12 equal to 3. If you look at the rate of change, you will find that all of the values are equal. It means we have a constant rate of change. Once we have a constant rate of change, it means this relation will be linear. Now we need to find if the relation is proportional or not. At the first divide, 15 divided by 5 will be equal to 3. 24 divided by 8 will be equal to 3. 36 divided by 12 equals to 3. 72 divided by 24 equal to 3. Once we divide y by x and all of the values are equal, it means this relation will be proportional. So we can find if the relation is linear or non-linear if the rate of change is constant. And we find the relation is proportional or non-proportional if y over x is constant. Once we have here the relation is not linear, it means there is no rate of change. It means this relation is non-proportional. The relation is proportional only if the relation is linear. The meaning of proportion, we have a straight line passing through the origin point. So check if the relation is proportional or not we need at the first to check if that's linear. If the relation is linear, we continue with the constant rate of change as the proportion. But the relation is non-linear relationship, it means there is no constant rate of change and there is no proportional relation. In question number 5, we have a relation between the degree Celsius and degree Fahrenheit. Look at x at the first. We have 0, 5, 10, 15, and 20. 5 minus 0 equals 5. 10 minus 5 equals 5. 15 minus 10 equals 5. 20 minus 15 equals 5. Now for y. 32, 41, 50, 59, and 68. 41 minus 32 equals 9. 50 minus 41 equals 9. 59 minus 50 equals 9. 68 minus 59 equals 9. Now look at the rate of change. If you look at the rate of change, you will find that will be constant because all of them will be 9 over 5. So once we have here the rate of change is constant, it means this relation will be linear. Once we have here a linear relation, it means we have a constant rate of change. So the rate of change now will be equals 9 over 5. Now we need to find if the relation is proportional or not by dividing y by x. So we have 32 over 0 and 41 over 5. From the beginning, you will find that they are not equal. It means the relation is non-proportional relationship. Now in question number 7, we have a relation between the time to the distance. If you look at x, which represents the time, you will find that 1, 2, 3, 4. In each time, we add 1. Now look at y. 4.9, 19.6, 44.1, 78.4. 19.6 minus 4.9, the answer will be equals to 14.7. So the rate for the first one, 14.7 over 1, which is 14.7. For the second one, 44.1 minus 19.6. By subtracting, you will find that the answer will be 24.5. 78.4 minus 44.1. By subtracting, you will find that the answer will be 34.3. Now find the rate of each value. The change of y over the change of x for the first value will be equals to 14.7 over 1, which is equal to 14.7. The rate of change of the second one, 24.5 divided by 1 will be equals to 24.5. After that, we have 34.3 divided by 1 will be equal to 34.3. You will find that all of them are not equal. It means there is no constant rate of change. Once there is no constant rate of change, it means this relation is non-linear relationship. Once the relation is non-linear, it means this relation is non-proportional. In question number 9, we need to identify if this graph represents a linear relation or not. At the first, we can check by drawing a line. If you draw a line, you will find that we have a straight line passing through the 3 points. It means this relation is linear. But we can check by using the table. Now the first point here, the order pair of the first point will be equals 8 and 80. That's 8 and 80. The second point is 16 and 60. We have 16 and 60. The third point will be equals to 24 and 40. We have 24 and 40. Now you find the change of x. From 8 to 16 will be equals by adding 8. 24 minus 16 is equals to 8. 60 minus 80 will be equals to negative 20. 40 minus 60 equal to negative 20. You will find that negative 20 over 8. The second one is negative 20 over 8. It means the rate of change is constant, so the relation is linear. And we can find the rate of change by dividing the change of y over the change of x, which is negative 20 over 8. The simplest form, by dividing by 4, you will find that the answer will be negative 5 over 2. If you look at the line, you will find that we have a straight line not passing through the origin point. Once the line is not passing through the origin point, it means the relation is non-proportional relationship. In question number 11, we have the same. We can check if the relation is linear or not. You will find that we have a straight line passing through the 4 points. It means the relation now is linear. You can check by using the points, so the first point that we have now is equal to 1 and 2. The second point is 2 and 4. After that, we have 3 and 6. Now look at the first point. Now look at the relation. From 1 to 2, we add 1. From 2 to 3, we add 1. 2 to 4, we add 2. 4 to 6, we add 2. You will find that the rate of change in all of them is constant. It means this relation is linear. Once we have a linear relation, it means we have a constant rate of change. So the rate of change will be the change of y over the change of x, which is 2 over 1. Once we have a relation represented by a straight line passing through the origin point, it means this relation will be proportional. And that's all about the constant rate of change.